Hello, today, let us explore the universe through the eyes of two incredible scientific instruments, the Hubble Space Telescope and the James Webb Space Telescope. These are among the most powerful tools humanity has ever placed in space. For many years, the Hubble Space Telescope, launched way back in 1990, was our sharpest eye on the cosmos. It orbits the Earth and has given us breathtaking views and changed our understanding of the universe. Even after more than 3 decades, Hubble continues its valuable work. It primarily sees the universe in visible light, the same kind of light our eyes detect, and also in ultraviolet light. Now, we have the James Webb Space Telescope, or Webb. Launched more recently, Webb is often called Hubble's successor. It cost around $10 billion to build and is equipped with extremely sensitive, cutting-edge technology. Webb is currently the most powerful space telescope we have, but Webb sees the universe differently than Hubble. Its primary vision is in infrared light. Infrared light is invisible to our eyes, but we can feel it as heat. Seeing in infrared is crucial for 2 main reasons. First, infrared light can pass through clouds of cosmic dust that block visible light. Second, very distant objects, like the first galaxies born after the Big Bang, have had their light stretched into the infrared spectrum as the universe expanded. So, Webb can literally look further back in time and see through cosmic clouds that Hubble cannot. The goal today is not just to look at pretty pictures side by side. It is to think critically about what these different views tell us. Let's compare some observations, but let's go beyond simply asking which one looks better. Let's ask, what new knowledge does each perspective offer? Consider the famous pillars of creation in the Eagle Nebula. Hubble's iconic image from 1995 shows majestic columns of gas and dust in visible light. It is truly beautiful. But when Webb looks at the same pillars in infrared light, it pierces through much of the dust. Suddenly, we see bright red spots within the pillars. These are newly forming stars, hidden from Hubble's view. This comparison teaches us directly about starbirth, showing us the stellar nurseries hidden within the nebula. It also reminds us that we see these pillars not as they are now, but as they were thousands of years ago, due to the travel time of light. Let's look at galaxies. When Hubble viewed the interacting Penguin galaxy, it showed the visible structure and shape resulting from gravitational pulls. When Webb observed it, its infrared view highlighted different populations of stars and potentially more details within dusty regions. When we look at distant galaxy clusters like MAXO 416, both telescopes see the effects of gravitational lensing, where the cluster's immense gravity bends the light from even more distant galaxies behind it. Webb's sharper infrared view can often reveal more of these lensed background galaxies, allowing scientists to better map the distribution of mysterious dark matter within the cluster and study the earliest galaxies in greater detail. Now, think about nebulae, like the Crab Nebula, the remains of an exploded star. Hubble shows the intricate web of glowing gas filaments energized by the explosion. Webb's infrared view reveals different structures, highlighting the distribution of cosmic dust and cooler gas, giving a more complete picture of the elements ejected by the supernova. Seeing in multiple kinds of light helps astronomers build a more complete understanding of these complex objects. Comparing their deep field images is also revealing. Hubble's ultra-deep field was revolutionary, showing thousands of galaxies in a tiny patch of sky. Looking back over 12 billion years, Webb's first deep field image, achieved in much less time, pushes even further back because it sees infrared light. Webb captures the stretched out light from even earlier, fainter galaxies that Hubble cannot detect. This directly helps us understand the dawn of the universe. Even closer to home, looking at Jupiter, the differences matter. Hubble provides stunning views of Jupiter's cloud tops and storms in visible light. Webb's infrared images reveal temperature variations, the structure of deeper clouds, faint rings, and tiny moons with incredible clarity, offering new insights into the planet's complex atmosphere. So, as we compare these images, let's move beyond personal preference. It's not really about which telescope is better. They are different tools, designed to see the universe in complementary ways. Hubble gives us the sharp, visible, and ultraviolet view, while Webb provides the deep, infrared perspective. Science advances by combining information from multiple sources and perspectives. The key is critical thinking. Ask yourself, how does seeing in infrared change our understanding of star formation? How does comparing these views help us trace the evolution of galaxies? What new questions arise from Webb's ability to see the very early universe? Hubble opened our eyes to the vastness and beauty of the cosmos. Webb is now extending that vision, allowing us to peer deeper into the dust and further back in time. Together, they represent humanity's ongoing quest for knowledge, pushing the boundaries of discovery and inspiring us to keep exploring the great expanse of space. Let us appreciate both, for the unique windows they provide onto our amazing universe.